Alright team, so you finally made it to nonlinear regressions. It's a great chapter. There is a lot to it, so we wanted to shoot this video, especially on how to do these in Excel. So what we have, and what you should have in front of you if you want to follow along, is we have this wine ranking and price data and a bunch of other things. And we want to estimate our 4 different nonlinear models. And then ultimately we'll find which one's best. We'll do that later. But I want to focus on how do we do these things in Excel. So I have already gone and kind of put things in order for you. So we're going to start with linear, which is what you've done in the past, and then build on it. So first, just notice I have the raw data here, and then if I go over here, I've gone ahead and I've cleaned this data for you. So I was missing some price data that I couldn't move, so I had to go through and clean that up a little bit. But I've already done it. I've put it so that my Y variable, what I'm trying to predict is price, is on the left-hand side. The right-hand side is rating. To be honest, you don't have to do that. It's just sort of, I have a little OCD, ADD kind of going on. And I always like Y on the left, X on the right. So for all of these, I've set it up kind of like that, and we're going to have to create anything else. But I've written out the model. So for linear, I just normal, right? Price on the left, rating on the right. So let's just jump in. Let's run this regression really quickly. So we can do data analysis. You'll probably have to scroll down a little bit, find regression. You'll do okay. And okay, my Y variable range, this ought to be second nature to you by now, is price. So I'll do Command Shift down to highlight it all. And you can hit enter, click back on the little box. My X range, you can either go from the bottom up, I like this, or you can scroll up and Command Shift down again, but I'll click on the very bottom. I'll do Control Shift up to highlight it all. I'll hit enter. I'll select labels because I did have these labels, and you almost always want to be honest, just because it makes life a lot easier, especially if more than one variable, 2 variables. What was X variable 1, 2, and 3? I don't want to create a new sheet because then I have to keep labeling them all. So what I'm going to do is I'm going to do output range. Click on this little button. I'll click on my little graph, and I'm going to say, okay, let's put my regression output in E. And you hit enter. And then, like always, you should be getting comfortable with this. We always are going to want to check our errors. I won't talk about it in these videos, so we can make it a little bit quicker. But we'll check residual plots. Should hit OK. We'll go through. We'll wait. See how long this is going to take to run our regression. Again, we have over around 100,000 observations, so it might take a little bit. And ta-da, we should have an output that you're kind of familiar with. Our goal here is to find the most accurate model, the model with the best, makes the best predictions, fits the data best. So before I kind of talk about any of this, I'm going to go through and I'm going to estimate the quadratic, the Lin-log, the log-log, the log-log, and then at the very, very end we'll say, okay, which one is the most accurate? If I had to go to my boss and say, right, this is the model, which one am I going to use? Because they're not going to have time, right? Your job is to run these 5 and be like, okay, this one's best. If you can't do that, well, then your boss is going to hire some other analyst or statistician or normal worker that can do that. So let's do the other ones. So let's go linear, one should be easy. Let's do quadratic. All right, so again, I have price and rating. I look at my model, so I have price on the left, and I have rating and rating squared. Well, I don't have a rating squared yet. We have to create it. So I'll go up here. I'll title this rating squared. You can do also caret 2, something like that, whatever you're most comfortable with. And then you'll just do equals. Well, it's as simple as the formula. It says rating squared. Well, this is the rating, so I'll click on that, and then I'll square it. I'll do caret 2. And I enter. I do that. And again, rather than doing that 113,000 times, click on your little box. You see the little bottom right arrow, double click it, and there you go. Now you're ready. My Y variable is price. My X variables are rating and rating squared. So let's do this. So we'll do data analysis. We'll run a regression. I'm going to make sure, so I'm going to highlight price again. It was actually already set up to do that, but I'll keep showing you. And then my X range, so I'll delete this. I need them both. So I need ratings over the rating squared, and then I'll do Command Shift down, Control Shift down, run your computer. I'll hit enter. Again, I have labels. My output range is fine there. Residual plots again. Hit OK. Again, this is going to take a second because let's see, we have 137,236 observations. If you have a little bit of an older computer, it might take even longer. Alright, so notice we were down here looking. I don't know why it puts the residual plots down here when I'm looking at it, so I'll cut those. It's going to work for me, and I'll go up to the very top. And there's my output. So I'm just going to put these up here so we can talk about them later. It's going to hurry up. All right, so we have the quadratic. Just some quick things you might want to know, like, okay, concave up or concave down. We always go to the square term. We look at this coefficient. It's positive, so it's concave up. Or you can think happy parabola. I don't like that, but if it helps you remember it, please do. So we have this shape that's kind of a U shaped like this, right? Happy parabola. It's positive. You can find the minimum points. You can go through those in the chapter, but that's not what this is for. So let's do the Lin-log. So I've written out the model. Lin, price on the left, Ln rating on the right. Okay, well I just have rating. What I need to do is I need to create Ln, and again you can title this whatever you want, and then go from there. So equals Ln, which is the natural log, open your parenthesis, and then I want to take the natural log of rating, right? So do that, close the parenthesis, hit enter, boom, double click it down. All right, you're set. Now you have your y, you have your x. The common mistake I see here is when you run this regression, you're going to try and put both of these in there like you did in the quadratic. You don't need that, right? I just need price and Ln of rating. So I'll do data analysis, regression. Again, I'll select my variable that I want to predict, which, because I'm clicked in this box, it's not letting me do it. I'm going to click out of there to do analysis. Regression, so click here. I'll do Control Shift down to highlight it all, hit enter, and again I need to delete this. I only want Ln of rating. Now you don't need rating in there as well. And shift down, all right, labels, output range, residual plots, perfect. I'm going to go up here and look because I don't want that output to put my graphs at the bottom again. So I'll do OK, and we'll have to give it just a second here. Alright, and ta-da, we got everything that we need. And so there's 3 down, 2 to go. Now we need the Log-lin model. And so notice Log-lin, I have the natural log of price on the left, and then I have just normal rating on the right. So you can create the variable over here if you want. I'm going to insert a column, so I'm going to right click on B and just do insert. And then I'm going to title this Ln of price. So I'll do equals Ln. Take the natural log of the price, and I'll close my parentheses, and again I'll double click it down. Now here's my y variable, here's my x variable, same thing, regression. Alright, regression, we'll set it up. So I'm predicting Ln of price, and I'm using just the rating. And again I'm going to go up here because my residual plot's on the bottom. Labels good, output range, residual plots, perfect. We'll hit OK. Again, it's going to take just a little bit. It's our second to last one, so not much longer. And there we go. So again, I've got log on the left, then on the right. It might be helpful to write these out before, because one weakness of this Excel output is like, well, it doesn't tell me what my y variable was, so without this, I might get a little bit lost. That's why I always love labeling these things down. So, last one. Last model is Ln of price, Ln of rating. So I need Ln of price, Ln of rating. I need those two variables. You can create them here. Let's show you a little trick here. So I'll do Ln of price. I better spell it correctly. Doesn't really matter. Ln of price, and then I'll do Ln of rating. So I'll show you a trick that'll save you 30 seconds. So you can do Ln of whatever your price was. So I want the natural log of this. All right, and you could go over here and do the same thing. Equals Ln and then of the rating. But if you want, if you drag this to the right, so if you go here and you click on your little double click, instead of double click it down, if you drag it to the right, it'll move that one over. So again, you're taking the natural log here, and then you can highlight them both and do your double click, and it'll do it for both. You could do them one on one. It doesn't really matter. So last one, data analysis, regression. All right, what am I predicting? Again, I want Ln of price because this is the log-log model. Then I'll go over here, and what do I want as my x variable? And I want Ln of rating. So it's my X range will be ln of rating, Command Shift down. Output, residual plots. I'm going to change the output just to go over one because I don't want it right next to the data, so I'll change it to F2, right? Huge change. I'll hit OK. And again, we'll get to wait just a second for it to predict for us, or estimate for us. And this one's taking a little bit longer. Alright, and perfect. Alright, now we have our log model. So, if you're just worried about how to calculate those, you're set. You should be able to do that. In the next video, I'm going to actually go through and show you how to pick which is the best one. But if you want a little bit of practice interpreting the coefficients from each of these models, I'm going to take about 5 minutes here and just walk through each one. So just interpreting coefficients. So for the linear model, again, I had price and rating. This one ought to be sort of pretty easy because it's just what we've been doing all thus far. So I'll just say as rating increases by 1 point, that's what rating is measured in, we would say price of the wine, what we're predicting, increases by $5.18. It shouldn't be a percent, should be dollars. And don't forget, on average, you could write all else constant, but there's nothing else constant in this model, so you actually don't have to do it in this one. And you're set. So there's your interpretation. Right, the p-value is 0, so it's significant. I'm comfortable with that. The one where students have a lot of problems with is this one. Right, so notice, right, it's a quadratic model, so we can't actually interpret this coefficients. We can't actually say as rating increases by 1 unit, the price of the wine increases or decreases, because we have to tell you where you're at. Right? The shape is this U shape. So if I were to draw it, let's see if I can do this in Excel. Yeah, I can. So it looks like this. So here's the shape. No, that's not what we want. I'll just, let's see. I don't want this. Let's do insert our shapes. This is what I want right here. So, right, you've told me that it's essentially this shape. Right, it's just, and again, it's kind of ugly, but right, initially, right, price goes down as rating goes up, which seems kind of odd. We'll talk more about that later in the class. But it's negative and then it's positive. What you can do, though, is find the minimum point. If you remember from the formula sheet, it's negative b1 over 2b2. So if I wanted to do x min, that's if I'm solving for that, well, what's our x variable? We'll say rating min. All we do is, so we'll do equals, do negative b1, which is this, right, divided by 2 times b2. We'll close this parenthesis and perfect, right? So we'll say, right, the price of the wine is minimized when the rating is 84.71. Well, so you'll notice from our data, the lowest rating that we see is 80. So really we're kind of starting here. How to find the minimum price? Well, we could actually just go in and we use our formula. So we have our estimated coefficients. We'll just kind of plug them back in. So the equals, we'll do the intercept plus this times, well, this is the rating that we found. And we'll do plus this times, again, this rating, but it's squared, so carry 2. Boom. So the minimum price that our model would predict at a rating of 84 is around $17.65. If we wanted to go back in our sort of old coefficient interpretations, we use the marginal effect. Let's see if I'm spelling this correctly. And our formula was, right, b1 plus 2 times b2. In our case, right, the marginal effect would equal, so b1 is that negative 132.325, and b plus 2 times 7, I forgot one, I'm going to confuse you all, so 0.781, and then times whatever the x variable is, so rating, again I need to put that up here, so rating, I don't want to forget my variables. And then, right, if you told me, all right, if I had a rating of 90, what would be the marginal effect? How would price change if I went from 90 to 91? Then you could do it, right? You could do it really easily. So then I could plug things in. So you just do equals. I would do my negative 132 plus 2 times this times 90. All right, so 8.25. So I would interpret this as, right, as a wine rating goes from 90 to 91, the price would go up by approximately $8.26 on average, all else constant. So this one's kind of the most complicated. It takes the most work. Moving on, Lin-log model. So in this case, it's only one side is logged. When we interpret these coefficients, I always want to divide by 100 wherever I see the log and then get it over to the right-hand side. Well, in this case, it's already there. So here, I would say that as rating increases by 1, it's got the natural log, so its units are percent. Then you would say sales price increases by this number divided by 100, and then dollars, because price in dollars, so $4.49 on average. And I hope that makes sense. The log-lin. So now I have the log on the left, so I would divide by 100, and then I have to get it to the right-hand side. So I would multiply this side by 100, multiply this side by 100, and then we could go. The units for rating are the same. The units for price will be in percent because it's logged. So you would say, as rating increases by 1 point, it's not logged, and sales, I should spell correctly, sales price increases by, so it's this number times 100, so 12.57, and then again, the log here means that that unit is percent. And then on average. And all else constant if you had other things in there. Last one, log. These are kind of my favorite. They're easy. So left-hand side log, right-hand side log. You would technically divide both sides by 100 and then get this 100 over to the right-hand side. So you're going to multiply by 100, multiply 100, it's going to cancel out. So all you need to know is price and rating are both in percent, and then it's easy. As rating increases by 1%, price increases by 10.97%. And then again on average. And all else constant if you want to stick with it. I hope this was helpful. Practice some useful tips. So again, this has a log on the left-hand side. This has a log on the left-hand side. So if we're making predictions, we need to use the exponential and the standard error. I'll talk more about that when we pick the best model. So I'll have this data kind of already set up for you next if you want it. Thank you. Have a great day.